Hello, Mr. Minnick, helping students in an Intro to Python computer science course learn how to trace for loops. So here's a typical situation out there in the world of coding. You would have a variable that's keeping track of something in your computer program, such as this, I don't know, a score in Fortnite or something. So let's just keep it simple and call this variable named sum. So we have sum, and sum is being set equal to 0. And I want to use a for loop to add up a running total. So we use the lowercase word for that works in many computer languages, including Python. Excuse my slightly sloppy handwriting, but I'm using a drawing tablet here, and it's kind of shaky. These things called for loops often use loop variable name I. So I is a variable, just like sum. It's allowed to store numbers. And I is going to take advantage of what's called the range function in Python, which is lowercase range, just like it's spelled when you sing Home on the Range. And range has a version where you can put 2 numbers as parameters in the parentheses, or 1 number. For this example, I'm just going to put 1 number in the parentheses. And the way a for loop works, kind of like a function, def, a defined function, it needs a colon here in Python. So that's called a for loop, and I is called the loop variable. Some people might call it an index variable, which is one reason why we traditionally use the lowercase letter I. For is the upper boundary for this for loop. More about that later. A for loop always has a body. The body could be 1 or more lines of code. I'm keeping it simple here, and I'm only going to put 1 line of code in the body. So I'm indenting this line of code as is required in Python. So usually I use 2 spaces, but I see other people that use 3 or 4. Anyway, here's the line of code that's in the body of my for loop. Sum equals sum plus 1. That looks strange to an algebra teacher, because that's frankly speaking illegal in algebra. If you subtracted sum from both sides, you would get the ridiculous result of 0 equals 1, which means there are no real solutions to something, or worse, there were solutions, but you messed up somewhere in your algebraic steps, and you're probably not scoring well on the Pennsylvania PSSA exam. Now, if you're watching this from California, maybe they take the CSSA. Oh, CSI. No. Keystones. Oh, I'm so confused on tests. You know what? We're doing coding here that solves problems in the real world. So let's forget about this algebra stuff. Now, algebra is important, but not for the rest of this video. This is called a call statement. I'm sorry. Whoa. It's called a counter statement. This particular example counter statement is an example where you're counting by 1 each time you go around the loop. If I put a 2 there, then you'd be counting by 2, and that would still be a counter statement. If I put a -1 there, it'd still be a counter statement. I'd just be counting by -1s. So a counter statement is typically used inside of a loop in computer science. And I'm keeping it simple in this video by putting just 1 there. Kind of like your birthday, when you add 1 to your age. Age equals age plus 1. Okay, so here goes. Let's trace this loop and predict what happens. Better yet, down here, a blank line below, let's, even with the F in for, let's type the command print, parentheses, sum, comma, I. I'll talk more about that when we get to it later. For good style, I always like to put blank lines around my for loops. So that's a blank line, and that's a blank line just for good style. to make my code more readable by other people. Anyway, let's trace the code and see what happens when we get to this print. So when you trace code, you should keep track of variables on your scratch paper. If you're ever taking a standardized test, like the AP Computer Science A exam, you might want to check your work as you go in the margin of the paper that they give you. Now, some people can do this in their head. Some people try to do it in their head and they get it wrong. You judge by doing enough of these problems which type of student you are if you are taking a standardized test. If you want to get a job at Google or Amazon or Microsoft, and as a code developer, software engineer, often you have to take a test that has loops like this on it. So just warning you. Here goes. Sum equals 0. I'm executing that line of code in my head. That means put a 0 into the variable sum from right to left. So let's reflect that by putting a 0 there. Next, so I did that line of code. Next, I get to 4. For I in range 4. That means put a 0 in the variable I. Now I know what you're saying. Where's the 0? Up here it was like very obvious. 0 goes into sum. Well, this is just the way a for loop works. When you only have one number in the parentheses of range, the variable, whatever you have here, whether it's I or J, or K sometimes is used, it always starts at 0. That's just the way it is. So I put that 0 there, so check. I've done that line of code. Now I go into the body of the Ferris wheel. I mean loop. Did I say Ferris wheel? Well, it's kind of like that. This is a loop. It goes around and around and around until somebody stops it. So we're in the loop right now. We're in the what's called the body of the loop that's indented here. And we execute the code that's on the right of the equal symbol here. And from right to left, we analyze this. Sum is currently 0. So think of that as a 0. If you're showing scratch work, you'd put a little 0 with your pencil there. And then you add 1 in your head and get a grand total of 0 plus 1 is 1. And that new 1 is the number that plugs into the variable sum. So the old 0 is crossed out and that new 1 is put below it on your scratch paper to reflect that. That was a lot of work just to analyze that counter statement, but that's the way it is. So I erase all that so that next time around the Ferris wheel, I'm not distracted by that scratch work. That's why I use pencil. So we just we did this line of code, but the way a for loop works is it knows to always go back up to the top for another go around. This time, we asked the ride operator at Hershey Park, here in Pennsylvania, here near Reading, Pennsylvania, there's a amusement park called Hershey Park. It's where they make Hershey bars next door. So if you're watching this video, like a lot of my YouTube followers are in different states, we have Hershey Park. So when you're on a ride, you look at the ride operator and you hope that he or she lets you go around again. Well, in this case, you do, because I did not get to the number 3 yet. So you bump I up by 1 because that's just the way it works. It always goes up by 1s unless you have 3 parameters in the parentheses here, which we don't in this easy example, so I'm glossing over that. We always go up by 1s. Okay, well, we didn't stop the ride yet because we're not at 3. So we go through the loop again, and that's the second time around both of these lines of code. At this point, sum is the value 1, and that 1 plugged in there temporarily plus this 1 is a grand total of 2. The 2 plugs from right to left into the variable sum. So that means I cross this 1 out, make it a 2. I did all that scratch work, so I'm erasing it with my pencil. I get to go back up to the top of the loop because that's the way it works. And we add 1 to I, and we ask the ride operator, are we at 3 yet? Nope, we're not. So that means we get to go through the loop again. By the way, that was the 3rd loop iteration that I'm currently on. I'm in the 3rd iteration. Each time you go around the loop, it's called an iteration. To go around the loop, it's called to iterate the loop. Well, anyway, sum plus 1 is currently 2 plus 1, simplifies to 3. The 3 plugs in the sum, crossing out that old 2. I always like to put single slashes through these old numbers in case you have to like go back and figure out where you went wrong when you're off by 1. You don't want to have to restart the whole problem. That's a pain. So now we got that new number 3 there. We go back up to the top of the loop. We add 1 to I automatically like we always do. And now the right operator says 3. You can go through the loop one more time because you're not at 4 yet. So we go through, I forgot to erase my scratch work from the time before. We get to go around the merry-go-round one more time. 3 plus 1 is 4. I used that 3 there. That 4 goes in there. Crossing out that, erase your scratch work just in case there is another go-around. Now, smart people see that there's not going to be another go-around, but I'm going to erase it anyway. We go back up to the loop, top of the loop, and we ask the right operator, if you click the little clicker that you have, are we at 4 yet? Yes, we would be at 4. So the right operator doesn't click. The right operator just stops you and lets you off the ride. We are now finished with the for loop. I think I lost track there. I think I had 4 iterations. So I kind of, if you are keeping track of check marks, I'd have 4 there. I usually do not ask my students to check mark things. That was just for the purpose of this video. I usually don't ask my students to draw these arrows, but I do ask my students on worksheets to reflect their scratch work this way. In fact, I'm very, very fussy. If you don't circle the final value that each of these involved variables take on, I sometimes take a half point or maybe even a full point off. For example, once upon a time, there was a student that was on a computer when he or she was supposed to be looking up at the screen, and then I took 10 points off for their classwork grade that day. True story. It happened on January 25th, 2019. In fact, I'm going to ask that person right now to turn his computer off and log off for the day, so you can focus on paper, like you sometimes are forced to during blackouts or on AP exams. Okay, we didn't execute this line of code yet, print. In the black console window that this website Replit gives you, it would print out the number that's stored in sum, which is a 4, and it prints out a comma, and it prints out the number that's stored in the variable I at this point, which would be a 3. Now, not that that has any meaning or context, but it is a good way to like check to see if somebody knows how for loops work. Eventually, we'll probably move turtles around with different colorful pens, but that's like tomorrow or Monday. Okay, variations of this that you're likely to see possibly on a quiz on Monday or any day soon. Let's say that instead of +1 there, we had a +2. So people that are in my classroom right now, recopy all of this down, please, as an exercise number 2. Keep everything else the same, but put +2 there instead of +1. In fact, rewrite it this way. Rewrite it using this fancy compound operator that's also legal in Python. Now that's the same thing as sum equals sum plus 2, which is the same thing as sum equals 2 plus sum, according to the law of commutativity that Python does obey. Anyway, this is a variation that you're likely to see a lot of times. So now let's redo the problem, but with that +2 there. Better yet, let's see if somebody in this classroom wants to make YouTube fame by taking a guess at the answer that might be one of the multiple choice answers on an AP exam question. Now, I know you're only in 9th grade, people in this room, but let's say that one of the answers here is 8, and another potentially wrong answer or right answer is 16, and another answer is 2. And they always give you A, B, C, D, and E, and a lot of times E is like none of the above. So right now, what's your computer science intuition? Sometimes I call it CSI. Sometimes you just can, like an ant, smell the ant trail by the chemical odor that was left by the other ant that would walk past there 5 minutes ago. Because I don't think ants have a nose. I think they just have an antenna and they like sniff it somehow. So who has that power? Okay, somebody who has the last name of Falloon. Which do you think is the answer there? So choice C, we have 1 vote. How about person whose last name Keister? 16 or 6? Or none of the above? Some. Some is 8, so we have 2 votes for 8. Let's see if that ends up being the answer or not. Okay, here goes. I'm going to go fast forward because nobody likes a long video, and they could like probably slow me down or speed me up on their own pace. So here goes. I want to trace this, but I have to erase my scratch work from the previous problem. And let's just see if those 2 intuitive people predicted the right answer. Well, overconfidence is not a virtue. Just saying, the person that just said I did, unless he tested it in Replit. But right now I'm just going to pretend that I don't know the answer myself. 0, check. I starts at 0. Sum goes up to 2. We go around the top of the loop. I bumps up by 1. We go through the loop. Sum bumps up by 2 more to a total of 4 so far. We go back up to the top. I bumps up to 2. We go through for another ride around the merry-go-round. It goes up to 6. We go back up to the top. I bumps up to 3. A ride operator does let you go around 1 more time when you're like 1 away from the limit. So it does go up to 8. It goes back up to the top. And in Python, unlike Java and some other computer languages, it stops there with the I. I doesn't go to 4. It stops. That's the final answer that I like circled. That is indeed the answer to this exercise. At this point, we've finished executing the loop. We are released to execute any code that's down here, which happens to be this. And because of the accidental double quotes around that, whoever said the answer was wrong. SUM prints out, and then the number 3 prints out. The answer was none of the above. I just changed the question on you, but I do have students that sometimes don't notice little sets of quotes like this that makes what looked like the obvious answer wrong. So they see the pattern and they get it right, but they're still wrong. No, wrong is wrong. You didn't get the trick behind the trick, I like to say. Like once upon a time, there was a student that thought that 10 plus 15, he or she thought it was 25. But really, this is the string 10, and this is the string 15, and the answer there to when they're concatenated is 1015. It all came down to the double quotes being there. That was a true story. Once upon a time, there was a student that got that wrong on a midterm exam. Anyway, good job to Falloon and Keister for getting the 8 right, because that was the right question. Okay, this is a long video, but I'm going to make it really short, this last part. I have one more example to do to make this class even with my other classes. So let's say this time you get 10 free points at the start of a game and starting at 0. Yeah, let's do that. That's kind of like a whole different variation here. So I erase all the scratch work while people in this room are copying all of this down. As a third example right now. And that was kind of fun, asking people to predict what the answer might have been. So this time, I'm going to start sum at 10. Everything else is the same. I'm going back to the sum equals sum plus 1 again. That variation is more, I'm going to do the plus equals 1 to keep it short. So this time, what do you predict is going to be the final value stored in sum? So I have anybody that just wants to call out something out loud because I don't want this video to take too long. what's going to print out as the value for sum this time when it goes up by 1 each time through the loop, but it started at 10, and the loop does 4 iterations? Well, I do have enough fingers. So I have 10 fingers up right now, and I'm going to, my 11th finger just went up, my 12th finger just went up, my 13th, yeah, I had extra fingers at birth, and my 14th finger just went up. I now have 14 fingers up. Yeah, I think it's going to be 14. If that's one of the answers and I'm in time pressure, I'm just going to circle it if it's a standardized test. But here goes. Sum starts at 10 this time, not 0. Check, we did that. I starts at 0 because that's just the way it is. Sum goes up by 1, up to 11. We go back up to the top of the loop. I bumps up by 1 because that's the way for loops work. Sum goes up by 1. I goes up by 1. Sum goes up by 1. I goes up by 1. The right operator does have us go through the body of the loop at this point. So sum goes up to 14. We go back up to the top, and the right operator stops us before we hit and collide with that 4. 3 is the final value stored in I. And yes, 14 is the final value of sum. So it prints out in the black console window. It prints out 14, 3. And now, as a bonus to any hot shot, what if I put 400 here? Something so outrageous you wouldn't have time on an evening of homework, much less the 1 minute that you have for each AP exam question. What if we put 400 there? And let's really mess with you. Let's put -2, just cuz. And let's change this to like a prime number like 3. Okay, I truly, as a 28-year veteran teacher who did really well on my SATs, I think I got it perfect, but on the math part. But I don't even know the answer to this. I'm going to pause the video and come back. So it just took us about 3 seconds. Somebody here is probably going to work at Google because a bunch of my former students do, like if they want to work at Google 10 years from now. So please come back and watch this video, but raise your hand if you said 1198 from the mobile choice. I have, just for the record, I have 3 hands that were honestly up. There's a last name, there's initials CC, SW, and KK. Ooh, has a ring to it. Any other initials want to claim that they did 1198? I don't like to put names on the internet. So, but 10 years from now, you might be famous. At 23 minutes and 7 seconds into the video. Okay, I don't have time to trace this, so here's the pattern. This number multiplied by this incremental step counter amount gives you 1200. And normally that would be the final answer, but I started this person at -2. So -2 is 1198. Now, if you want to iterate this loop 400 times and find all the scratch paper that you need and then not be off somewhere in the middle, good luck with that. But there are plenty of patterns here. And computer scientists that love code find those patterns and they make the next version of Instagram better than the old version by taking advantage of these patterns. Or curing cancer by doing human genome medical big data research and finding patterns that can help bring faster cures to the marketplace and to the right patients, but avoid the patients that show other symptoms. Okay. I leave it up as an exercise to the viewing audience to type that in and leave comments in this YouTube if it was wrong. I hope it wasn't. Have a great day.